Okay, this activity, what we're going to do is we are going to take the available pressure that we have at the building control valve, and then we are going to subtract the pressure loss that we're going to have, or that's going to occur in the water meter. We'll also subtract the pressure which is going to be required at our controlling fixture, and then to round out this sheet, or the front page of this calculation worksheet, we're going to also take into consideration the pressure loss due to elevation between the building control valve and the controlling fixture in feet. So, in this example, I have right now come up with a pressure available at the building control valve of just shy of 45 pounds. We're at 44.78 pounds of pressure. And the next thing I need to do is determine what the pressure loss will be through the meter. And so if you look back here, we had selected that we were going to install a 3/4 inch meter. So with that, I am going to go to the appendix of the code book again, and there I'm going to find a graph that has the pressure loss through cold water meters, displacement type water meters, and we're going to figure out how much pressure loss we would have pushing the gallons per minute of this building through that water meter. So to do this, what we're going to do is we're going to start on the bottom side this time of the graph. We're going to start down here, step number 1, and we're going to insert our gallons per minute of our building. We're then going to read upwards until we intersect with the size meter that we're going to have. And so we'll call that step number 2. And once we've read from the bottom up into the intersection, then we're going to read to the left, and step number 3 will be to record the pressure loss through the water meter. So let's do that. The gallons per minute of the building was predetermined to be 22.2 gallons per minute. We'll use that 22.2 gallons per minute to determine what the pressure loss is through the meter. Find 22.2, which we're just going to go with 22, which is right here. And now we're going to read up with that until we intersect with a 3/4 inch meter. And so I'm going to just stay on the 20 GPM line until I get there. It's a little bolder. Okay, so now I'm at the 3/4 inch water meter. Now we were at 22.2 GPM, so I'm going to go 21, 22 GPMs, and I'm going to make sure I'm all square here with my lines. Alright, and we're going to intersect right about there. And we said it was about 22.2. I'm going to make a tick mark right here at the closest line. And as I look at that, it appears that we're at about, we got 6. We'll call this 7, this middle line here. We'll call it 7.5 psi loss through a 3/4 inch meter. So I'll go back to my calculation sheet, and we'll take that 7.5 psi. We'll subtract that from our value of 44.78. We'll take that off of there, and that'll drop us down to 37.28. Okay, next thing. Calculation sheet is asking for the pressure at the controlling fixture. The controlling fixture is the fixture which is the most demanding, which has the most demanding pressure to operate properly, which includes the following when determine fixture performance: loss due to instantaneous water heaters, water treatment devices, and backflow preventers which serve the controlling fixture. We're going to call it the pressure balance valve in the tub shower. And according to our code, we're going to lose, or that fixture is going to require at least 20 psi to operate correctly. So that means I'm going to have to subtract that from my subtotal. So we're going to take off another 20 from there. And now I'm down to 17.28 psi. Okay. Last step on the front sheet here is to take the difference in elevation between the building control valve and the controlling fixture, and we're going to select 20 feet as the difference in elevation. That would be something we'd have to predetermine from a print, a drawing, something from the field that would give us an actual elevation difference. And so for this one, we'll take 20 feet, and we'll take our 20 feet times 0.434 psi per foot, and in that 20 feet we're going to lose 8.68 psi. 8.68 psi. Now, last step, take our 17.28, subtract 8.68, and we will be at 8.6 psi at the bottom of the page.